let's look at our first problem. We're going to rewrite these expressions as exponents, or as we say in mathematical terms, exponential form. It's really quite easy to do. All we have to do is identify the base and then raise it to the exponent, and that's the number of times that base appears. So let's look at our first one. We have 6 times 6 times 6 times 6, 1, 2, 3, 4, or we can rewrite that simply as 6 to the 4th power. Again, here's our base 6. The exponent 4 represents the number of times we're multiplying that base. Let's look at our next one. We have negative 11 as the base, notice, all the way across. How many do we have? 1, 2, 3, 4, 5, 6. So we can rewrite this in exponent form as negative 11. And again, that was 1, 2, 3, 4, 5, 6. So we write it to the 6th power. We say that in mathematical terms as negative 11 to the 6th power. Let's look at our final one down here. This time our base is not a number, it's a variable, but we treat it just as we would a number. We have w times w times w. So our base is w. How many do we have? 1, 2, 3. That represents our exponent of 3. Let's see what we have next. This time we're asked to evaluate these following expressions. The first one is 3 to the 5th power. What we're going to do is write it without exponents. Remembering what the exponent means, this 5 means we're going to multiply the base 3 times itself 5 times. That gives us 1, 2, 3, 4, and 5. So this is the same thing as 3 to the 5th power. The rest of the problem then is to multiply all these 3's together. Let's begin. 3 times 3 is 9, times 3, 27, times 3 is 81, and times 3, 243. If you need to use pencil and paper to help you in your calculations, please do so. So 3 to the 5th has the same value as 243. Let's look at our next one here. This is a little bit different. Notice in this problem, we're adding these two together. So let's first of all evaluate each of these separately. After we do, then we'll look for their sum. So 2 to the 2nd power means there is 2 times 2. Plus 3 to the 3rd power tells us the base 3 is multiplied by itself 3 times. So there's 1, 2, 3. So the rest of the problem then is to look at these products. 2 times 2, 4, plus this product. 3 times 3 is 9, times 3, 27. So finally, all we have to do then is add 4 plus 27, which is 31. So 2 to the 2nd plus 3 to the 3rd adds up to 31. Now you need to pay close attention to these next two problems. We're going to evaluate the following expressions. Negative 2 to the 6th power and negative 2 to the 4th power. Now when you just glance at these, they may look very similar, but the big difference is this first expression up top has parentheses. The second one does not. Let me show you how that affects the problem. With the parentheses around the negative 2, as they are in this top problem, what that means is the base is negative 2. Exponent 6 means negative 2 is multiplied by itself 6 times. Let's write that out. This becomes negative 2 times 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 negative 2. 1, 2, 3, 4, 5, 6. Now, remember our rule for multiplying sign numbers. If there's an even number of negative signs, our product is positive. So that tells us, since we have 6 negative signs, we're going to end up with a positive number. And now the rest is just to multiply these two together. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2, 64. So negative 2 in parentheses to the 6th power is a positive 64. And the reason is because the negative is part of our base. Now let's see how we can contrast this with our second problem. Notice again, there are not parentheses in the second example. So what does this mean? Without parentheses around the negative 2, it tells us that the base is simply 2. So we have 2 raised to the 4th power, which means 2 times itself 4 times with the negative out front. Let's write it down to see what it looks like. It looks like this. There's our negative sign. We only have one notice this time. We have 2 raised to the 4th power, which means 2 times 2 times 2 times 2. One negative sign, remember the rule? That means we have an odd number of negative signs, a negative product. So that gives me negative, multiply the 2's together, 2 times 2 is 4, times 2 is 8, and times 2, 16. So notice this time we have negative 2 to the 4th power equals a negative 16. This is a very important distinction to make between the two. Base, negative 2. Base, positive 2. Because there are no parentheses that would include the negative sign, notice it sits out front. Base 2, base, negative 2. Make sure you keep that straight because that'll avoid lots of problems in the future. Let's evaluate these next two exponential expressions. Let's evaluate 0.3 to the 4th power. Now the only difference here is that we now have a decimal that we're going to raise to the 4th power, but the procedure is just the same as if it were a whole number. What we're going to do is rewrite it as 0.3 times 0.3 times 0.3 times 0.3. Again, remembering that the 4 represents the exponent, or the number of times the base is multiplied by itself. So let's just multiply the numbers and then we'll add the decimals at the end. 3 times 3 is 9, times 3 is 27, times 3, 81. Now an easy rule or trick that you can remember when you're multiplying decimals is just to count the number of decimal places and then include that number in your solution. We have 1 decimal place, 2, 3, 4. That means our solution will have 4 decimal places. Remember that 81 has the decimal place to the immediate right, so we're going to count over 4 decimal places to the left. 1, 2, and let's put our placeholders 3, 4, and then add our. So 0.3 raised to the 4th power is simply 0.0081. Let's evaluate our last expression here. The first thing we're going to do is raise each of these numbers to its exponent. Remember, 2 is the exponent. 2 represents a number. We're going to multiply the base times itself. That gives me 4 times 4 minus. Now notice there's no parentheses around the minus with the 2, so it's just a minus sign between these two terms. 2 is raised to the power. That means we have 4 2's, or 2 times 2 times 2 times 2. There we have 4 of them. Now let's just evaluate. 4 times 4, 16. Minus, let's look at this product. 2 times 2 is 4, Times 2 is 8. Times 2 is 16. 16 minus 16, our nice number, 0. So remember, all you have to do is identify the base, identify the exponent, and make sure you multiply the base times the number in the exponent, times itself.